talk about basically just education in general, learning 5 times faster. And this is really targeted at programmers who are already past the school stage and trying to keep up to date, or at the tail end of the school stage. And some of this is definitely applicable in school stage as well. But what it's like talking about doing your own education, right? Being in charge of your own education versus when you're in primary school or even university, you kind of have your education sort of mapped out somewhat, and you're in a teacher-student setting. But once we get beyond that, how do we continue to learn? And that's very important for programmers, right? We all have to learn, and we all have to learn. The faster we can learn, the better. That is a really, really, really key point here, is that as a programmer, we're all well paid. Programming is an industry that pays very well. So whether you are already a programmer or you are on your path to become a programmer, being a programmer, you are well paid. So therefore, your time becomes very valuable from a monetary standpoint. The more effectively you can learn, the faster you can learn, the better it is for you, right? Because it minimizes the amount of time that you waste learning and maximizes the amount of time that you can spend applying that learning and applying that into making money to support yourself and your family. So learning faster is very important for programmers. Plus the fact that programming is possibly the industry that moves the fastest of all industries. Developments are just coming breakneck speed, especially in the front end world. And so there's always something new to learn, and it gets very overwhelming. So learning how to learn those sorts of things faster. And by the end of this webinar, what I will do is actually map out for you a plan, right? Follow this plan and you will learn in general 5 times faster than what you're doing right now. Or what you're experiencing right now. But I'm also going to go through and explain what the problem is and the science behind everything, and why this is an issue, and why it's possible to see such huge increases in the amount of time it takes to learn, or such huge decreases in the amount of time it takes to learn if you apply the proper science. And I listed here, learn anything 5 times faster, but the reality is it can be as much as 10 times faster depending on different factors. So let's go through this here. So this is what the experience is now. Once you already, again, I'm talking of if you're already a programmer and you are already you're past the primary education or secondary education stage, or if you're teaching yourself, if you're learning to become a programmer, but it's very self-directed. This is essentially what goes on right now. So first, you might watch a conference talk or two about some topic, some item that you really want to learn. And once you watch that conference talk or two and they show you how to code something up, you say, wow, that was awesome. I loved getting to see how to do that thing. But man, I don't remember anything that they talked about, or at least how to do it. But I remember the fact that you can. So then you may go and you start looking at blogs, or a blog comes up in some feed or something. Oh, there's a blog, and you end up reading a blog, 2 blogs, 5 blogs about the topic, 10 blogs. And every time you read the blog, you feel like, all right, I'm getting it a little bit better, but I still don't really feel comfortable with the topic yet, right? I'm not quite ready to go off and try doing this on my own. And then you end up saying, all right, I'm going to buckle down. I'm really going to learn this. I'm going to go take a course. So I'll go over to one of the many places where you can subscribe and take a course. And so you take a course. And at the end of that course, you think, I'm still not quite there. I still don't feel comfortable with it. But there's this other course I just found out about, like the ads came up when I Googled blah, blah, courses on whatever. And so this ad came up for another course, and I'll bet that course, that will get me there. And so you go through that second course, and then you're still not quite comfortable, and finally watch a third course. By the time you're all done with all of this sort of stuff, one of 2 things happens. Either you start to feel comfortable enough and start implementing it, or most likely the result is that you still feel lost. And that's the experience that many programmers and a lot of programmers have, and this varies from instance to instance, but this is the experience that we get all the time when trying to learn something, is we go and consume all this material, and still at the end, you still don't feel comfortable with whatever it is that you're trying to learn. And there's a lot of effects of this process, of this going through a ton of different content and still not end up feeling comfortable with the topic at the end. First off, it could be very demotivating, right? You're watching this stuff over and over again. You really want to start applying it, but you get very demotivated because you're spending a lot of time and energy trying to get through this. So, and that you can also end up feeling stupid, right? You know that everybody else is already knows this topic. Maybe the other people on your team are more comfortable with it, or the people that you're seeing online, they're experts in this. They've got it down pat, and you're trying to learn it. You just can't learn it, and you might end up feeling like you're just not as smart as other people, which is, then that sets in a comparison. Oh, I'm not as good at learning as other people. I learn slower than other people. I have to go slower. And this comparison sets in. Maybe I'm not as good of a programmer, and I'll never be as good of a programmer as such and such other person, right? And in my 25 years as a developer, I've definitely heard many times people saying, I learn slower than other people, but eventually I do learn stuff. I hear that all the time, which I actually think is very incorrect. I don't think that they learn slower than other people in general, but they presume that they do because they compare their pace of learning to the pace of learning to where other people are already at, right? It's a little bit like getting out onto the soccer pitch and comparing yourself to well, Pele's not playing anymore, but Ronaldo, right? There's this expert that's already out there, and you're trying to learn and follow along and do what they do, and it's coming very slowly, and you feel like, well, they must learn very fast. But what you don't see is the journey that they went to get to where they're at. It can also lead to abandoning your plans, right? You spend time, you're learning X topic, and after a while, you haven't gotten it, you haven't been able to implement it, so you just stop learning that topic, right? Which ultimately wastes your time. A recent example of myself, a couple of years ago, I decided I was going to learn Vue. So I went through one of these courses online and walked through this course on Vue. And after I went through the course, other things happened, and a couple weeks later I was still not feeling comfortable with actually doing it and using it in any projects, and so I didn't. And here 2 years later, I've absolutely forgotten everything that I learned at the time that I was going through that course. So I absolutely wasted my time because I didn't actually learn it. So these are very negative effects. So now this like learning 5 times faster doesn't even account for the fact that if you spend a bunch of time on something and then just abandon what you're doing, right? Now it's like an infinite waste of time, infinitely more effective if you can learn faster, because you actually do apply and learn the topic versus spending time and not even learning the topic. So it's important to understand that education is a process, right? It's not a single thing that happens. Learning something is not just a single event. It's a process, and this process has many steps to it, right? There's a lot of steps to education, and we have to understand those different steps and how they fit into our education plan, or into any education plan, so that we can identify what steps we're involved with, what steps exist, and if there are any steps that are missing, and how to bring those steps, those pieces of education into our learning plan. And so if you look at the content, the learning, and the education that's out there for people that have already become programmers, they're past the school stage where they're paying somebody for school. If they're in that stage of continuing to learn and continuing to learn new things, the content that exists in that space only provides one step of the educational process. And I'm going to detail out for you the steps of the educational process, but content today only provides one step. So if you think that consuming content is the process of learning, the content that already exists, say, go over and take an Egghead course or a Pluralsight course or whatever, a Udemy course, if you think that that's the process, then you are gravely mistaken, because they are giving you only one step of the process. And so therefore, you have to do the rest. Now, ultimately, it would be nice if these educational places gave you all the steps, but who is ultimately responsible for you, for your education, for learning and growing as a developer, or whatever thing you might be trying to be learned? Who's ultimately responsible for it? Who's going to both benefit if you do it and learn it well and effectively, or pay the price if you don't? It's you. So you have to take ultimate responsibility. So putting the responsibility on the content providers is unfortunately not an effective tactic. So you have to take responsibility for the entire process and understanding it and implementing it. So the problem here is that the existing content today is passive. And I want to talk a little bit about this concept of passive education. But before I do, I want to just talk very briefly about the fact that there are two really key things that go on during learning. The first one is retention, and retention is the aspect of what do you actually remember of what you learn tomorrow, for example, right? If I learn something today, what do I remember tomorrow? As an example, if we put up a list of 100 digits in a row, and I look at that, I might be looking at it and viewing it, but tomorrow I'm never going to remember those 100 digits. And maybe something that I could remember, say 5 digits. Let's say that we had 5 digits in a row, and we could all sit here and memorize those 5 digits. The likelihood that we remember those 5 digits tomorrow is actually very low. Right? That's retention. So if I learn something today, but I don't know that thing tomorrow, then that thing is valueless to learn unless I only needed to know it today. But really, all that matters is what I actually know tomorrow. It doesn't matter what I know today. And this is actually a problem because it could be very misleading to watch content, either a conference talk or a course, and start to feel like, oh yeah, I'm getting this. All right, cool, I can do this. And we feel confident and we feel like we've got it. And then tomorrow we go to do it and we've forgotten most of what we've learned. So it's very misleading to actually feel confident in the topic, whatever it is, the content you're consuming. And you should be aware of that. You need to be aware of the fact that if you feel like you're getting something, that might be true in the moment, but it doesn't necessarily make it true tomorrow. So you have to focus on retention when it comes to learning. The other half of learning that's very important is motivation, right? And motivation is an important part of education. As an educator, Brooke, who opened us up, Brooke has a master's degree in education and has studied this very much. And in an education program where you learn how to be an educator, they'll talk a lot about how to keep students motivated, because a demotivated student is completely useless. If you get, as we talked about before, the problems with the current process and how we spend so much time and we end up getting demotivated and all those negative things that happen. So proper motivation is really important. And I'll talk about, as I lay out an effective learning plan, I'll talk about how motivation plays into this process. So let's go back and we're going to talk about passive versus active. So some of you may have been exposed to the terms passive versus active when it comes to learning. And I'm just going to briefly summarize what passive and active learning is. Passive learning is when the student is very passive in the process. So a good example of this is watching a conference talk or attending a lecture where you just sit and listen to the person talking. That's passive learning. Active learning is when the student is very active in the process. And a good example of that would be learning to ride a bike. And it's not a single, learning isn't necessarily exactly one or the other. It's more of a spectrum, right? Different types of learning could be more passive. Different types of learning could be more and more active. And you can engage more and more activeness into learning, or depending on, incorporating things into learning can make it more and more active. So you can push it up the active scale. And this is very important because passive learning, when we just sit and listen to things, we will only retain 7 to 15% of what we actually learn. And it's important to understand how low that is and how much of a waste of time it could be to consume and spend time consuming something and only remember 7 to 15% of it. And if you understand that your learners are going to be passive if you're a teacher, then you can incorporate that into what you're teaching and do a lot of, say, repetition so that they get the same concept over and over again, and they're more likely to remember what's important. Active learning, on the other hand, gives anywhere from 75 to 90% retention. Okay. Now, if we do simple math here between these two things, this is where we come up with this 5 times and 10 times faster thing. So on the high end of the passive scale is 15%. On the low end of the active scale is 75%. The difference between those is 5 times. So if you have the most effective passive experience, you'll remember 15%. If you have the least effective active experience in learning, you'll remember 75%. That's 5 times faster. But on the bad end, if you're passive learning, if you're down at the bottom end at 7%, and active, you're up at the highest end at 90%, right? That's actually over 10 times. So really the variation is as much as 10 times more effective if your learning is active. By the way, the only thing that's more effective than active learning is teaching, where if you teach something, you are going to learn upwards of 90% of what you teach. So, but it's hard to teach. You have to go out and find opportunities to teach. So if you really want to learn something, volunteer to teach it. So understanding these numbers and how passive and active learning, which is what's available to us, or what's easily available to us, is these types of learning. Understanding this and the difference between these is very important. While I'm at it, I want to talk about something very important that not everybody understands when it comes to looking at the existing material out there, and that is that typing is not coding. All right. So if you go and you find a course online that says, hey, I'm going to teach you X, right? Let's say GraphQL. I'm going to teach you GraphQL. And you can download the project and you're going to be able to follow along with me so that you're actually coding along with me, right? This is the great lie of current education, right? That by typing along with the learner, with the teacher, that you are actually coding along with them. You are not. Typing is not coding. Typing is typing. So if you download that project and you watch the video and they're typing and you're typing along with them, you are not practicing coding. You are not engaging in coding. You are engaging in typing. And to reiterate that, or to cement that in, my father-in-law, who works in metal fabrication, he knows how to type. I can sit him down and set him up on a computer with a project, and he can watch a video and he can type along with that, right? And at the end of that, he won't have learned anything that the teacher was trying to teach, right? But he will definitely pass and be able to type what the teacher typed. Typing is not coding. In fact, courses that have you type along and encourage you to type along, and I myself have made many of these courses because that was how I was taught how to teach. Courses that do that are actually have a negative effect because you are doing a mechanical task, typing, while the teacher is teaching and trying to impart principles and learning to you. So while you're doing it, you're distracting yourself with a mechanical task of typing. As an analogy, imagine if you went to a lecture at a university and the professor said, all right, I'm going to talk about the history of whatever. And while I'm talking and lecturing about this, I want everybody to juggle, right? That would actually take away from your learning because you're sitting there trying to your brain is engaged in one task while it's also trying to engage in another task. Sure, it's a purely mechanical task while you're listening, but your brain will take away some of its ability to learn by doing the mechanical task. So if you come across courses that say download the code and type along with me, and I'll talk about how to effectively use those, but don't type along with them while you watch the course. And I will lay out exactly how to deal with courses like that. But don't sit there and type along with them. You will actually learn less. If you've done this, you may have had that experience where you get to the end of a video and you click save and they show you what it's supposed to have done, and you pull it up and you pull up the web page or whatever and you refresh it and hope that everything worked. And when it does, you're like, oh, yes, I got it all right. But then at the same time, you think, I didn't hear a word that the instructor was saying because I was busy typing and constantly pausing and rewinding the video to type in what they were saying. And I didn't have time. My brain was so busy trying to type that in. I didn't have time to actually listen to what they're saying, and you might end up even watching the same video again. So this is a really important. Typing is not coding. So let's talk about a natural example of learning. And that is learning to ride a bike. If you were taught to ride a bike from a parent, or if you've ever taught a child to ride a bike, there's a couple ways to do it. There's the training wheel way where you just have training wheels and you need to slowly raise them up. But a lot of people learn to ride a bike in a more active way where the parent or an adult sits with the child or works with the child to actually learn to ride a bike. And that's going to be the process I'm going to talk about, because if you haven't seen it, you've probably seen it in pop culture. And it's a really good example of a good learning process, right? So the first step to this is that the learner has had the correct behavior modeled to them, because you don't actually the parent doesn't necessarily get on the bike and ride around and show them, but what the learner has seen is other people riding a bike. So they know what it looks like to correctly ride a bike. So they've seen the correct behavior modeled. Then the tutor, the instructor, gives them detailed tutored introduction or instruction to the topic. They introduce them slowly to the different pieces of doing it. They break it down, and however they do it. They might explain how the the brakes, the handles or brakes, or how the brakes work on the bike, depending on what the brakings are, how the pedals work, right? How the handlebars are, how to hold the handlebars. They'll explain all of these things. And as they do that, they also then ask the learner to engage in those activities. So this is how you hold the handlebars. So climb up on the seat and hold the handlebars like this. All right. Now this is what the pedals are for. This is how you put your feet on the pedals. Put your feet on the pedals, and you have to pedal this way, not the other way, right? And they slowly then show the student how to do these various things, the learner. And then they might start walking forward with the learner. And at the moment that they're walking forward with the bicycle, the adult is holding onto the bicycle and they're essentially operating the bicycle themselves. The learner, the student, even though they're holding onto the handlebars and they have their feet on the pedals, they're actually not doing anything. And then the teacher slowly says, all right, now, let's try turning the wheel or the handlebars left and right. Okay, now start pushing. And then the teacher can feel as the student is actually like pedaling and pushing. And they gradually release the responsibility over to the students. So they slowly give the student more and more responsibility until at some point they take their hands off the bike, maybe for a moment or two. And then there's that time where they take their hands off for a minute, and then the kid is maybe wobbling and almost falling over, and then they bring them back and they put their hands back on the bike and bring them back up, and they do that for a while, and then finally at some point they stop and the student is off riding the bike on their own. This process is the gradual release of responsibility, right? The instruction was given, and the student slowly takes over, right? And then the student has this opportunity to reflect on what's going on. The adult will tell the child, notice how when you brake and push back, this is what happens and how it feels. And the student is processing this sort of information. And there's also repetition going on. All right, now get back on the pedal. All right, do it again, do it again. There's a lot of repetition going on. An important part of the learning process. And it's very important to understand that at any point in, at least in my knowledge, any child learning how to ride a bike, was there a DVD involved, watching some video, right? You can't learn to ride a bike by getting a video, watching the video, or having the adult say, get up on their bike, ride around in front of them and say, that's how you do it. Here's the bike, go, right? Like that's not how learning works. The student and the teacher are very involved with each other, and they slowly release responsibility over to the student. So let's talk about the key principle that's going on here. And this is the key principle that is missing in essentially 98 to 100% of all content that's out there right now. And that is the principle of generation. So what is generation? Generation is when you are asked to generate the answer to a problem. If it's a mechanical task like riding a bike and you know that you need to brake, you have to generate how exactly you move your feet in order to brake the bicycle and apply the brakes, right? If it's coding, you have to figure out how do I do this type of binding, right? How do I use an array to do this thing? Whatever it is, there's a problem and you must generate the answer. When we learn math, the teacher might teach you what is 2 plus 2, or the teacher might teach you that 2 plus 2 is 4 and 2 plus 3 is 5, and then ask you what's 2 plus 4. And you have to then generate the answer based on what you've learned about the principles. This process of generation is the key process in learning, is you learn to generate the answers to problems, whatever those problems are, whether that's memorization problems or mechanical problems or theoretical problems or programming type problems. As you learn to generate those answers, you are actively engaged in the process. And this is what active learning is generation, okay? This is the key principle in active learning, is generation. If you are not doing generation, if you are not engaging in generation, you are not doing active learning. All right? You must be involved in generation, and that is active learning. And that's the problem with all the content that exists out there. Is think of all the conference talks that you've seen, all the blogs that you've read, all of the courses that you've taken on various topics. How often do they say, I've taught you this thing, now here is a new scenario that's different than the one we just talked about, so you can't just repeat the same answer. Here's a new scenario that involves the same principles, and we need to apply the same principles. How do we solve this new scenario using what we just learned? That would be generation. And how often does that happen in existing content? Almost never. Speaking as an expert here, because I made many courses, over 24 courses, and almost never did I involve the student in generation. I simply involve them in passive learning. And that's the problem with content today, is it's entirely passive. So It's break time, and we're going to move on here in a second to talking about the role of teachers and then how to create a learning plan. But it's time to have a little break. So, Brooke, you got a poll for us?
I do. I'm excited, and hopefully I don't disappoint you with this question. I actually have two questions, but I think the first one we'll pass on for now. So let's go to the second one. I really love podcasting. It's like this secret thing I discovered I really enjoy doing. And so this is about podcasting, but it's kind of a different spin. So let me launch the question here, and I will allow Joe to participate. But my question for you is, which podcast would you listen to first? There's Star-Lord's awesome music review, The Heart of the Matter with Tony Stark, Mind Tricks and More with Obi-Wan Kenobi, It's About Time with Doc Brown and Marty McFly, the Dinopocalypse with Alan Grant and Lex Murphy, Are We There Yet with Doctor Strange, and Happy Hour with the Hulk.
Those are awesome.
This was fun.
Oh
this was
gosh.
fun to come up with. I was sitting there thinking, what am I going to do this poll question on? And of course, I'm putting out today's podcast for ng-conf. And so my mind has been on podcast all morning, and this is what came out.
These are all podcasts that need to exist.
I kind of have this secret thing that I think you and I need to make one of these happen. Like, seriously, how cool would that be to have like Mind Tricks and More with Obi-Wan and Master Eames?
Yeah.
Master Eames and Avery.
That's great. No Captain America. Oh.
Oh, yeah.
What would
Sorry,
Captain America's podcast be?
Yeah, good question. Fitness.
Fitness. Yeah, the fitness podcast of Captain America.
So true.
Yeah. Patriotism. We could have a podcast.
There you go. That would be a good one.
Mm-hmm.
Oh, man. How to deal with being frozen. Right? I guess you could do that with Han Solo, too.
Right. Yeah. Oh, my gosh. How to do the Frozen podcast with Han Solo and Captain America.
The Carbonite. Carbonite sucks with Han Solo. We're dealing with the modern age. Now, that is the podcast I think that everybody needs right now.
Yeah, exactly.
Oh, man. By the way, does anybody know who Lex Murphy is? I would not have known that without looking that up.
What was that podcast? That was the
Dinopocalypse. Yeah.
Lex Murphy.
Alan Grant. So
I don't know who Alan Grant was, but
yeah, Jurassic Park.
The main character in Jurassic Park.
So Lex Murphy is the little geeky science girl. The niece or whatever she is.
Oh, that was Lex, right?
Yeah.
She was the niece, or niece of the. She wasn't Dr. Grant's niece. She's the niece of or granddaughter.
Ellie, yeah. Ellie, you're right.
The owner of
what's
Jurassic
his
Park.
Face? Hammond. But see, I didn't want to put him.
Mm-hmm.
So okay, do you want me to show the results, or should we hold on to it?
No, let's see the results. Let's see what we got.
All right, here we go. Mind Tricks and More with Obi-Wan. That would be kind of cool. The Heart of the Matter. That would be a funny one, I think, with Tony Stark.
Are you showing the results? I don't see them.
Oh, do you not see them? Sorry, everybody. Hello. There you go. There you go.
Oh, wow. Yeah, that was a clear winner. That was the one I picked.
Yeah. The Mind Tricks.
I think that would be the most useful thing, right?
Yeah.
Like, you don't need to see a second form of ID, right? That would be really...
So true. See, and I think even Happy Hour with the Hulk, because a lot of people, it's easy to get angry, nowadays. I think there's just a lot of crazy energy going on around us, and it's easy to just kind of get like anxious and stressed out. So I don't know, that one could be helpful. Yeah. Star-Lords would just be fun, but Mind Tricks would be pretty cool.
I was going Star-Lords was almost my pick, but with Obi-Wan.
Yeah.
All right.
Cool.
So let's get back to it. I'm going to talk about the role of teachers in learning. And there is a great question that was answered, or asked, Evan answered, or asked, do you include generation in your new courses? Yeah, the quick answer is yes, and I'll talk about this at the very end about what to look for in courses that are more active. And mostly the point today is to talk about how to take the existing passive content that's out there and make it active and incorporate it into a full learning plan. So that'll be what we finish up with is that. But yes, we do everything that THINKSTER does is active learning, and we'll talk a little bit about that. All right, so teachers. Not necessarily everybody understands this, but if you ever had a coach or a tutor, if you learned piano or went to soccer and had a soccer coach, played soccer as a kid or adult or anything. My son is on hockey. He suddenly decided, he's 16, he suddenly decided he wanted to play hockey. I don't think he skated more than 3 times in his life. So that's been pretty interesting. But the value of coaches and tutors, we all sort of assume the value of a music teacher, for example, is to teach, right? I took piano. I learned to play the piano when I was a kid, and I definitely showed up and my teacher taught me piano. She would explain to me what the music does. But there's a very important second aspect of the value of a teacher that not everybody consciously realizes and thinks about, and that is assigning proper exercises, right? The other thing that my music teacher did that was very important was not only did she teach me like what the music itself, what the notes meant and the different things on the music, and if I was struggling with something, she'd help me figure out fingerings and that sort of stuff. But it was also assigning me the proper exercises. So picking the song, the next song for me to learn based on my current skill, the thing that pushed me just enough. And there's a scientific terms for this. Brooke, it's a zone of proximal
Development, the ZPD, zone of
ZPD.
proximal. Yep.
Zone of proximal development, right? If the exercise is too hard, one, you'll either get demotivated, but you also potentially won't even learn anything when trying to accomplish it, even if you could accomplish the exercise. If it's too easy, you don't learn anything because it's not incorporating new stuff, so you're just doing the same thing over. Even though repetition is important, we'll talk a little bit about why exact repetition is a lot less valuable than repetition that slowly builds, right? So the zone of proximal development, that's having an exercise that pushes you just the right amount. So
the best analogy I've ever heard with that one is like a rubber band. And you want to think of just stretching it just enough so that it's not slack and loose, but that there's enough tension on it that if you kept it around something like, around like a can of soda or something that has it just pulled tight enough, eventually over time it would actually become kind of loose. It would lose a bit of its elasticity. So you want to pull it just enough that the student over time will become comfortable with it, but you're just pushing them outside their comfort zone just enough that they're slightly frustrated, but not so much so that they're defeated, if that makes sense.
Yeah. So that is the value of teachers, right? And that's when we're engaged in active learning, right? Piano, soccer, sports, that sort of thing, having a tutor, right? We're engaged in active learning. The teacher is assigning us these things, or at primary school, right? Learning arithmetic. That is the value and the role of teachers. But right now, the content that we consume, teachers are only engaging in the first half of their responsibility. And this is kind of understandable because who is it that's teaching us programming techniques? Is it called, well, outside of college, right? Outside of university. But if I want to learn GraphQL and I go onto YouTube and look at GraphQL, who's teaching me GraphQL? Is it a university professor? No, it's another programmer, another engineer who decided they wanted to start sharing their knowledge. And so they learn GraphQL. They start telling everybody they're the ones who wrote the blog or did the conference talk or maybe got ambitious and wrote a whole course on the topic. They're engineers. They're not teachers. This may come as a great shock to some people, but education is a science, one that we've been studying as a species for well over 150 years, right? You can go to college and get a major in education, right? So we would laugh or chuckle, at least under our breath, if a teacher said, I'm going to start programming without ever learning how to program, right? But as programmers, we decide, I'm going to start teaching without ever studying how to teach. right? And that's what happens. Every YouTube video that's on programming, almost 99% of them, conference talks, blogs, they're all written by programmers who haven't studied how to teach. So let's talk about building knowledge. Building knowledge is like building a building, right? You have to start off with a foundation. You have to build a framework up of that thing. And then you slowly fill this in with details. And this is a really important part of the process to understand that learning is not a simple matter of some knowledge is imparted. That knowledge gets put into place, plugged in wholesale into our brain, and then we begin applying it. No matter how many movies, Hollywood movies have implied that, say, like The Matrix, right? I'm going to download the piloting program for, or the Kung Fu program, and now I know Kung Fu, right? That's not reality. Learning is a process. It's like we build it up over time. And a teacher's value comes in those exercises, how they teach things at the right moment, they give exercises at the right moment, they slowly build up our foundation. Then they build up the framework on top of the foundation, and then they fill in details. And that's a process that we have to be involved in as well. This can't happen solely from watching one talk or going through one course. This is the process of building knowledge, and this is as we learn things over and over again. Those who have been programming, say, on some kind of a front-end framework will know that you can work in a framework for a year or two and still have plenty to learn and still be filling in details. In fact, one of my recent blogs and videos that was really popular was what most Angular developers don't know about template bindings. And template bindings are essentially about the first thing that's taught when you learn Angular, right? So it's one of the most basic concepts. And yet I've discovered that so many Angular developers who've been programming with Angular for years don't understand some key pieces about template bindings, right? We go back and we fill in these details. So this is the part of the repetition, right? We start with a foundation. And we have this foundational knowledge. And then we come back and we revisit a lot of the same topics, and that builds up our framework, our frame around the building, or whatever analogy you might have in your head. And then we come back and revisit. And again, now we're filling in more details. And each time we're learning more and more and more. So repetition is, again, an important part of the process. So the problem is that right now, I've said this many times, current content only gives us the first piece. So let's move into what it means to actually have an effective learning plan. So I've been talking about this whole time, and incidentally, by the way, have I been modeling active or passive learning? Right? Type it into chat. What have I been doing? Have I been doing active or passive? Passive, yeah. All I've been doing is talking at you. Part of the problem is in something like this, it's very conceptual. It's hard to really practice. But there's a really key piece here. The other part of the problem is I only spent so much time preparing this webinar, right? I could have spent more time and come up with active processes and exercises for you to engage in as we're learning. And I even had a couple of ideas, but I was limited on time as I prepared this webinar. So you are experiencing passive because, and this is one of the reasons why we only get passive learning with all the content that's out there. It was easier on me. It was quicker on me to not try to figure out how to engage you in active learning. So that's why you're only getting passive. That's why we've been doing passive. One of the big reasons why I've been doing passive learning. So it's important to see that, and it is understandable, right? Like, as much as I might talk about how bad it is that all the learning that's out there is passive, and people don't, the teachers, they don't understand education. They're out there trying to teach, right? I myself did the same exact thing. I was actually taught to do this, and I still engage. I write blogs, which are very passive. I like to write blogs. I do YouTube videos now and then that are very passive. I give conference talks that are very passive. It's a lot more cost effective to produce just the material and put all the burden of the rest of the process on the learner. So with that realization that the burden of the rest of the process is on you, let's talk about how that process can work and work effectively, and how to actually implement a plan that you will learn things 5 times faster or even 10 times faster. So the first part is to consume the content, whatever that is. I said watch, but really I should have put the word consume. Whether that's reading a blog post, watching a conference talk, watching a YouTube video, watching a course, whatever. Consume the content. But now it's very important. A good rule of thumb is to consume no more than 10 minutes maximum of that content. When I teach people how to do courses, I do a lot of teaching course authors how to author courses. The ideal video length is 6 minutes plus or minus 3. So anywhere between 3 and 9 minutes. So that's why it's a good rule is go 10 minutes max. Try to find a natural place to stop and break while consuming the content, but 10 minutes maximum, especially if it's very deep knowledge. If maybe there's a video about the background of the technology where they're just telling you the history and something that you don't necessarily really need to learn, then it's okay to violate this. But a good rule of thumb is consume 10 minutes of content maximum. While you're consuming the content, take notes. Now, I've talked to a lot of people who have said they don't like taking notes, or when they do take notes, they find that they're distracted, and so they're not fans of taking notes. They've been told to take notes without necessarily having lived other people's experiences. I would say in general, a good for most people, taking notes, if you find it to be ineffective, is probably because you were taught incorrect processes for taking notes. Recently, my 16-year-old daughter, well, it was when she was 16, she's 18 now, but when she was 16, I was talking to her about studying textbooks because she was in primary school and high school and learning, and she had a textbook, and I asked her, like, what about, underlining? I was asking her about underlining and highlighting, and she was like, no. And I was like, has nobody ever taught you how to consume a textbook? And she was like, no, I just, I go and I read the textbook. And for her, learning how to properly consume a textbook was something she'd never been taught. Taking notes is a similar thing. Learning how to properly take notes is very important. Part of actually being effective at taking notes. So, like many other things, if you do it wrong, it can be a detriment. But if you do it properly, taking notes can be very good. Now, if you get out there, you can find YouTube videos on how to take notes effectively during lectures and things like that. But a general rule is just the whole point of taking notes is you're focused on what the teacher is saying. When the teacher says something that you realize that's a really key thing, is to write that thing down, right? And the point of notes, most people think that the point of notes is to review the notes, to have something to go back and review. So they're trying to get a copy of the content on their notes. That should not be the primary purpose of taking notes. Sometimes it is for other reasons, like if you're in a meeting and taking notes. But when you're actually learning, the number one valuable purpose of taking notes is not to have something to refer to later on. The number one valuable purpose of taking notes is because when you hear something that you know is important and you stop and write that down, that concept and that learning will be processed in different neural pathways in your brain as you write that thing down. And it will reiterate it as essentially a form of repetition, right? And that will cause that thing to stick harder in your brain, to use very layman's terms here, to stick harder in your brain, and you are more likely to remember that thing. Right? And so in a sense, you're almost picking and choosing what from the lecture you actually want to remember, because you aren't going to memorize the lecture, but instead when they say, hey, you should take notes, you write down, take notes. I'm sitting here explaining 25 things, but all you write down is take notes. And that is this prompt to you, and your brain is thinking about what I'm doing. And as you write that down, it may prompt you to write down a couple of subnotes about that as you're thinking about and processing that information. And your brain becomes very active in that information for that moment, right? That is the number one value of taking notes. Having notes to refer to later on, that can be valuable, but it's completely valid to take notes and never refer to them again. Because just that process of taking notes of the valuable things, the things that you realize, I want to remember this is key, and taking notes on that causes your brain to process this in neural pathways. And the brain is essentially just like a muscle. It's different than your bicep, but you build your bicep by stretching it. The more effort that you put in when you're doing some sort of a workout, that will cause the muscle to grow faster. Learning is the same thing. If there's no effort involved, then there's essentially no learning involved. Learning takes effort. And sometimes we hide that behind games, but learning always takes effort. Next, go ahead, Burke.
Here, because Alex over in the chat brings up a good point, and he's saying taking notes amplify his kinesthetic learning, scribble learning. But that kind of brought up a question that I have for you is, does it matter if it's taken on the computer or does it have to be handwritten?
That's funny since we have like the expert in education here asking Joe,
Well,
the enthusiast in education. But yeah, so my answer to that would be it can have a difference, but I don't think that. I think that there's still value. I think it's a little bit better to write, and you probably could maybe chime in on studies or science beyond this. I do think it's a little bit better to write by hand, but I'm still like a lot of times it's just not feasible. So taking notes with typing is definitely better than not taking notes. But I think I'm not 100% sure here, but I think there's good and bad in it because typing can go really faster. Like I can type in the word take notes really quick, and writing it out takes a little bit longer, a little bit more effort and more coordination. So I think that actually is far more effective of getting the concept in than just typing out take notes, right?
yeah. Actually, that's exactly it. I think that the research shows that handwriting your notes will help it sink into your brain more. I think if you want your notes to look back and reflect on them so that you can create more of that like photo memory, that's fine if you type them out for that reason. But for what you're describing, where it's the actual act of note taking that's beneficial, it is more tedious, it is more time consuming, but handwriting is by far and above more effective. So, get good at taking bullet point notes, but there's something to be said for actually getting your hand moving, putting pencil to paper. So just something to think about.
Right. And a good highlight of one of the values of the science of education, they actually do studies. What is or is not most effective. And so studying the science of education can really help you both as a learner and as a teacher. Okay, so you watch some content, try to keep it to 10 minutes max while you're consuming the content or consume content. While you're consuming the content, take notes. So next time you go to a conference, you can literally walk away with 5 times as much knowledge if you simply actually use, a lot of times they provide you the pad and the pencil or the pen, or bring your own and just take some notes as you're watching a conference talk. Just like have that there and be like, oh, that was really cool. And then take a quick note. You can walk away with a lot more knowledge than you would otherwise.
I have to interrupt again really quick. Everybody, that's his dog. That is.
Is it pretty audible?
Yeah, it's not like weird bodily noises.
It's not just one dog. That noise happens because this dog, the Chihuahua.
Oh, Superman.
Yep, he's in a Superman costume. And this dog, the mini Australian Shepherd, she is attacking him. And so he's growling at her because she's like all over him like a rat on a Cheeto. And he's growling at her. So that's what that noise is.
So
apologize,
funny.
but my dogs love to hang out in here in my little recording booth. They love to come in here. And then, as I said, the one dog gets on top of the other dog. And so if you actually notice, like every so often I seem to like turn in my chair. That's because I'm like kicking the dogs out of the side here to get them to be quiet.
Stop talking.
Yep.
Stop growling.
Yep. All right. So, okay. Now the next step, while you're consuming that content and you take notes, is then to practice. And ideally, you'd practice after about 10 minutes of content. Ideally, you practice. Now, this is where it gets really difficult as a learner because you just learned something. To actually implement and practice what you just learned in 10 minutes or in the last 10 minutes can sometimes take you a lot of time just to set up an environment to actually practice that. Tools like, if you're learning a front end, JavaScript-y, tools like StackBlitz can really help to get to that point. Or if the course does have the downloadable code, right, to follow along with, one of the really nice things to do is actually download more like the finished code and then go in and find a piece and try to implement the same thing that they've done in that project. Try to implement the same thing, but your own version. So if they showed you how to, say, do routing in Vue, right? And you can download a finished Vue product that has routing, go implement a new route to something. And again, this can be difficult, right? So this is a part where if they haven't set up the exercises for you, imagine like you're learning algebra and they teach you, but they don't give you the homework and you have to come up with the homework yourself. You're like, crap, right? 2x plus 5 equals 8. And you have to start thinking up your own practices and then do them, right? And that's essentially what you have to do at this point. But it's really important to not get very far before you practice. And again, practice is not, don't download the starting code and type along. You do. I'm going to kick them out. Don't download the starting code and then type along. Because all you're doing, that's essentially just repeating memorized information. Don't repeat memorized information. That's way less effective. So don't just type what they typed. Even trying to remember what they did and repeat exactly what they did, oftentimes that's still a lot less effective than coming up with your own idea and trying to implement that. So this one is really important, but it's also really difficult to actually implement, especially in an ideal setting. So as much as you can, try to practice this, but again, active learning. So do generation. Give yourself a new scenario applying what they just taught, and then try to make that happen and see what you can. And what's really important here is that even if you fail, even if you try it and can't get it done, you'll actually still be engaged in active learning and still retain 5 times more than if you just didn't even try. An important part, another next thing is to actually take breaks. For sure, take a break every 50 minutes. There's variation. I don't know, Brooke, you could chime in here as to what the ideal length of time is for taking breaks, but sometimes every 20 minutes I've heard, or every 30 minutes. The Pomodoro method is what, 25 minutes on, 5 minutes off?
I think this is something that you just have to, I mean, obviously the older you get, the longer you can go. I think a general rule of thumb is like every hour, but really it's something that you know yourself better than anyone else and you know what your limits are. I think also just paying attention to yourself. Every lecture is going to be slightly different. You may not be as interested in one topic as you are another. So just be very honest with yourself. If you notice you're drifting off and kind of getting that zombie look, go take a break, go stand up. Just a side note, notice that we took a poll. We took a brain break here in this webinar for this exact purpose.
Right.
So good job, Joe.
Yes. Yeah, so take breaks. And again, for a lot of different purposes, even when you don't feel like you need to take a break, if you spend a good hour, it's probably a good time to take a break. But definitely notice, are you feeling less engaged? Are you getting tired? Whatever, stand up, take a walk, whatever. That's actually a really important part of the learning process. And there's I'll give you some references at the end here. But there's a lot of really interesting science about taking breaks. All right. The next thing this is another key part, is having a personal project to apply what you're learning, right? So this is really detailed towards programming, but can kind of apply in just about anything else. If you're learning piano, have a song that you're trying to learn for yourself, right? If you're doing programming, have a personal project. If you're trying to learn React, have a website you're trying to build for yourself in React, right? This is a really important part because of the motivation factor. You'll be a lot more motivated to work on something that you care about than something that, yet one more to-do application, right? But if this is something that you care about, you'll be a lot more motivated to work through it. And then finally, spaced repetition, and you can Google that term. There's a lot of interesting stuff about that, but that is basically the idea that you need to learn something, and then after a short amount of time, review what you've learned, and then give yourself a longer amount of time and then review again. And that's how you convert things into long-term memory. So this can happen naturally if you're involved in the process regularly. But if you say only have time on the weekends to study, right? So Saturday you take 4 hours and you're studying, right? And then you go the entire week without doing anything more, that's really ineffective. So carve off some other time, even if it's just 5 minutes a day or here or there, but to review the things that you've done and have that spaced repetition.
All the more reason to take notes too, because you can reflect back on the notes. So if you don't have time to go through another tutorial or sit there and practice, at least you have 5 minutes, maybe while your eggs are cooking in the morning, just to look back at your notes or something,
And so this is a way to have an effective plan, learning the content that exists out there today, right? But and notice that it involves you not consuming the content the way the content producer assumes you're going to consume their content. If it's a YouTube video, a 20, 30-minute YouTube, I get so frustrated when I find these hour-long introduction to Angular YouTube videos, or sometimes 3 and 5 hour long introduction to, they think that you're going to sit down and watch for 3 hours, and suddenly that is so ineffective, right? You have to be responsible for turning just the very, very, very first step of the plan, that's all they give you, turning that into a full plan that's actually effective. So, and of course, diligence is a really important part of this too. Start the process and work through it. But as you stay motivated, as you actually practice and learn, see that I'm getting this stuff, as you work on a personal project and see it grow, that will actually make a big deal. So as an example, this is how I learned to study. I was very lucky. when I learned to program, how I learned to program, I was very lucky because I was going through a class on Pascal, if anybody's heard of that language. And as I was going through the class, I was playing Dungeons and Dragons a lot with my friends. I was about 16 at the time. And I had this idea as I learned the very basics of Pascal. I was like, oh, I could make this roll dice for me. And this would be a lot quicker than manually rolling dice. And so I wrote that. And then I had more ideas about building this little tool that I used while I played Dungeons and Dragons. And it was super motivating to me. So I never once felt like I was like learning and it was tough, because I was just excited to learn new techniques that I could then apply to this program that I was building. Right. So I very luckily fell into a very good process. And this is a time when, I did not have a lot of active learning available to me. I did have a class, but mostly I was learning out of the book, right? Just a textbook. But I applied the rest of that process to what I was doing, and just sort of by accident and naturally did that. So just as a quick note, over at THINKSTER, right, we're talking about how to learn things. THINKSTER, we do things very differently. At THINKSTER, if you take a course, you actually watch the content, then we actually give you a small exercise, one that the author actually designs for you, right? That's similar to what they just taught, but different, so that you actually have to go through the process of generation. And it's usually set up in a stack blitz exercise. You just click a link and boom, it's open, and you get right to actually doing the exercise. And then we continue on, and that process repeats a bunch of times. Then you'll get a larger exercise to summarize several things that you've done. So again, that spaced repetition, we revisit, we learn something, we fill it in, we fill in that foundation, then we revisit, and now we build up some of the scaffolding. And then after a larger piece of a course, we have project courses. And in these project courses, you're asked to actually build a project. And in those cases, we don't just ask you to build a project, say, go build this, right? Which you could do this on your own. And we don't do this, hey, just watch me code up something, which you find all the time. Right? We can find those all day long. Instead, what we do is a pairing system where we're not trying to teach new principles. Instead, we're just trying to cement them in by actually building something with what we've learned. And in that case, you're given an assignment to build this next piece of a full application. You build it, and then the teacher shows you how they would have built that same piece. So you see if there's anything that you did that maybe you could do more effectively or do differently. And then once the teacher shows you how they would have built that same piece, and if you got stuck, you can see what the answer was. Then they just give you the next assignment. Now build this piece, right? And move on. And so it's very much like a pairing session. And so it's still very active. That's what we do at THINKSTER. Which unfortunately I took over THINKSTER very much because I was learning all these educational principles, but I was over doing courses at other places. And I realized that what I was doing was very passive and not nearly as valuable as I thought it was, even though over 1 million people have watched my courses, and that I still was producing less valuable content, and I wanted to produce more valuable content that let people learn faster. And so that's why I took over THINKSTER and came on board at THINKSTER as the CEO. And I've been authoring courses over there and teaching other people how to author. So a couple of final points here. We're done. I don't see any other open questions. If you have any more questions about this, please throw them into Q&A and I'll answer them. But a couple of final things. First, some references, and then a couple of notes. One, check us out over at THINKSTER. We have a limited selection of courses. There are places that have a lot more courses, but our courses are very active. So the value of them, for this essentially the same price, is still 5 times more, because you get to learn a lot faster and a lot more effectively. And you have a much reduced chance of wasting your time. But 2, also, if you're ever interested in authoring courses online, we actually have a whole course on how to author technical courses. And we're always looking for more authors. And then finally, a couple of references. I didn't create a slide for these, but there's one book that I highly recommend if you're interested in the science of education from an enthusiast standpoint. There's a book called Make It Stick. That's my favorite book for this. And then there's a Coursera course called Learning How to Learn. Those are my 2 favorite recommendations for just the science of education in general and learning about education without having to go through an entire degree program. So it looks like there's no questions here. Christoph, you start with Pascal too. Yeah, Pascal was cool. I loved Pascal. Been 25, almost 30 years, I think now. since I learned Pascal, or have done any Pascal, but that was cool. Yeah, so if that's it, I guess. Thanks everybody for attending, and thanks for listening. I love talking about this. The book was called Make It Stick. I'm gonna type those two things into the chat. Make It Stick. If you're in the US, you can get it usually on Amazon. And then the Coursera course is Learning How to Learn.
We did get a question there. It says, is it also recommendable the Dreyfus model to learn faster?
I have no idea what the Dreyfus model is.
I'll be honest, I haven't heard of that one either.
Should we do a quick Google and see
if we can?
Let's do,
yeah.
All right.
Dreyfus model.
We have I'm over here teaching, but we actually have an expert here in education. Dreyfus model is skill acquisition. Wikipedia.
Acquires skills through formal instruction and practicing.
Based off recollection.
Yeah, I think it's just a name of, it's a different name for basically the same principles that we've kind of been going through. Right. Expert, proficient. Absolutely, because what you're doing, it goes back to, if you remember at the beginning, Joe was talking about the gradual release of responsibility. And to me, this Dreyfus model looks basically like the same idea, where it's this idea of you, the teacher, are the one who starts off with all the knowledge, and little by little, you're transferring that knowledge to the student, to the learner, and they're gradually taking on more and more of that responsibility. At first, they're just watching you as you ride the bike. Then they're sitting on the bike seat themselves, but you're still holding them up straight. Eventually, they take over and pedal and keep their balance themselves. And that looks like what this Dreyfus model is. They're going from novice, they have the training wheels on, to taking the training wheels off, but maybe they're still shaky and mom or dad is still holding the bike up. And then eventually they become the expert. They're over in the BMX park, jumping off those, whatever, like the little bumps and hills. So I think it's the same thing. Looks to me like that. I'm glad that you brought that to our attention though, Scott. I'd never heard of that one. That's pretty cool.
Yeah, it's cool. Okay.
It says, do you have any ideas to help break down a large knowledge set like this?
I do have some ideas. I'll walk through what I personally do when I have a large knowledge set to go through, and maybe Brooke can give some chime in as well. So I do have some stuff like that, but for everybody else, we're quite a bit over what our scheduled time was. So for those, everybody else, thank you for coming. And then I'll answer this last question, and then we'll wrap up the actual recording here. So thanks again for everybody. I love the opportunity to talk about things that I'm passionate and care about. So thanks for attending. All right. So do you have any ideas to break down a large knowledge set? Like you said, I'm trying to certify as a Google Cloud engineer, having trouble applying these principles because GC is huge and has influence. Yeah, I for one thing, I feel very much the same thing because we use AWS, and just logging into the panel at AWS, there's 45 different things. And every time I think, all right, I'm going to learn a little bit of AWS. And so I jump on and watch some YouTube videos. It's like, I can't even get a YouTube video that says starts from just lays the foundation. I feel like they're focused on one very specific thing off on the side, and I don't even know what in the heck they're talking about, right? Very large knowledge set. So for me, there's definitely a few things that are important to keep in mind when going through an extremely large knowledge set like what you're talking about, certifying as a Google Cloud engineer. The number one thing is, I think, to find somebody who breaks down the entire set and gives you the map. If you can't have the map of the entire set and where your knowledge lies in all the pieces of the map, you're going to be very lost. So finding that, no matter what it takes to find that, if you have to enroll in a course, get on Fiverr and find somebody who will give you 30 minutes just tell them, I just want to lay out and understand the entire thing. If you don't understand what the entire landscape is, right? That's the very first thing to navigating from point A to point B, is just understanding what the entire landscape is, even if you don't know any details. Be sure that you have a clear concept of the entire landscape. And I've seen some cool things like this for web development or for design where people will lay out all the technologies, but just understanding the entire set is the very, very, very first most important thing. Then I would say you should spend a good 10% of the time that you actually spend learning should be strategizing about your learning. If you're very self-directed, if you're just going through somebody else's course, just walk through their course, right? If you buy one of these like Coursera courses that give you the mini certifications, right, then they've done all this work for you. But if you're doing it all on your own, you should spend at least 10% of your time strategizing about your learning, right? So, and maybe as much as 20% of the time. But if you spend 4 hours actually studying something, take 30 minutes to an hour and just look at where you're at in your entire learning process. I like to do different types of charts and graphs that show where I'm at in the whole process. Like I've laid out for myself, I'm going to learn these 10 things. And of the first thing, I feel like I'm 20%, I've identified there's this one course and I'm 20% through this 4-hour course on this topic. And so that's the more strategy of learning. Where am I at in my learning process? And that will help you stay motivated as you see yourself moving through and seeing your progress. It will help you stay motivated, right? In something like Google Cloud, it could be really hard to come up with personal projects, but still some of that strategy time should be coming up with how can I apply what I'm learning, right? But spend at least 20% of your time. I call this the difference between swimming and popping your head up. So if you swim effectively, if doing the forward, your head's down, you have no idea where you're going. So you can swim for a while and you can actually drift off course. Every so often, if you're swimming out in an open, large body of water, if you're not in the pool with the lines painted below you, if you're in a large body of water, you need to stop, pop your head out and look around and see if you're still heading at where you're trying to get to. So those are my two best recommendations for a large body set, is to devote a significant percentage of your time, 10, 20%, to strategizing about your learning, understanding where you are, charting yourself out, just going out and finding, hey, when I get to this piece, what are things about that? Spending time just looking at YouTube videos, not watching the videos, but doing a search and seeing what are all the materials that are out there, and then organizing what videos am I going to watch, which videos am I not going to watch, or maybe spending some time. I'm just going to watch the first minute of 10 videos and figure out which video I think I actually like and which one is going to be the next thing. But don't get myopically and just be, paddling in the water and never look. Brooke, what about you?
Well, I agree with you, and I do have to put in some caution there as well, because it's really easy to get stuck, like to go down rabbit holes. So when you're learning something, I think it's important to stay on topic and not get distracted by, oh, well, what's this and what's that? And then all of a sudden, 5-10 minutes later, you're like, up to your nose and all of this other information that's just distracting you, and it's adding confusion. So I think really sticking to that particular topic, but just like re-emphasizing the importance of, taking those breaks, like learn something, take a break. And then I really want to put an emphasis on going and teaching it. Even if that's, in web development, I had never heard of this outside of this field, but the rubber duck theory, and just taking what you've learned and teaching it, even if it's to a rubber duck. I think there's a quote, I'm pretty sure it's Albert Einstein, and he said something to the effect of, if you can't explain something to a 5-year-old, you don't understand that concept well enough. So make sure before you move on from something that you understand it well enough that you could teach it to a brand new programmer or to a junior level programmer, and they could understand it. And if you don't have that, that foundation, then I would say keep studying it, keep focusing on it before you move on. But unfortunately, it kind of is your job to do what the instructor should have done. The instructor should have created modules and micro learning. And if they haven't done that, which, like Joe was explaining, most courses haven't, it's kind of up to you to look at the course and just say, okay, find little points and breaks where like you self-chunk things together and create your own micro lessons, and then focus on little bits and pieces, and don't move on until, like I said, you have that knowledge to go and explain it well enough to someone else. That would be my recommendation.
Cool.
Yeah.
All right, next question. What is your take on learning a new framework versus learning the basics of an underlying language first? It's a great question. I love this question. In general, my recommendation would be to focus on the framework first and the language second. And as a personal example, about a year ago, I decided because the THINKSTER application is actually written in Rails, I decided I wanted to learn Rails, right? So I found this place that had two courses, one on Rails and one on Ruby, which is the language that Rails is written in. I chose to do the Rails course, right? And the reason being that this is it was a very practical choice, right? I could learn a lot of things about the underlying language and get really good, but still know nothing about Rails. But I could learn some Rails and not really necessarily understand Ruby and why Ruby was doing things a certain way, but at least understand this task and all of a sudden be productive. In today's world for programmers, right, being productive is very important. If you're trying to get your first job, they'll be far more interested in if you can use their framework than how great you are in the language. Meaning, and I know that might sound a little bit funny because they're certainly going to ask you questions about the language, and if you suck at the language, you're terrible at JavaScript, you know a little bit of Vue, and they're doing Vue. That can make it hard to get past the interview. But still, if you know JavaScript well, but you don't know any Vue, they'll probably have a harder time deciding to bring you on than if you know Vue, but you're struggling on the JavaScript side. From a practical standpoint, I would focus on the framework first. There's another aspect of that as well, and that is, as you're learning the framework, you will encounter things about the language that don't make sense, and that will prompt you to go learn something very specific about the language. It also, I think, and that process can help you stay away from getting, driving down a rabbit hole of, all right, I'm going to learn the language and I'm going to learn everything about the language, but yet never learn to practically do anything in the language because you're getting all this sort of, I wouldn't necessarily call it theoretical knowledge, but all this knowledge about something underlying, but yet everybody's doing React and you don't know any React, you just know JavaScript, right? So my recommendation is to focus on the framework, but allow for some time to, when you encounter things in the language, dive off on a little side path for a minute and figure out, well, why is it that in this thing in the language, they're doing it this way? Why is it that works that way, right? And spend a little time understanding that, but get right back to, all right, what's the next piece of the framework? So that's my own personal.
Like you and I both love to build Legos, and I would think of it in a similar way where, you know how when you open up a new kit and they've put like bag 1 and bag 2 and bag 3, and so you're building just a portion of whatever it is bag by bag. And it's kind of the same way here, where you want to focus on one thing, I think, at a time, but really like what you're doing is building an entire Star Wars ship,
right,
or whatever it is, or the castle or the pirate ship, but you're doing it kind of in chunks, like what we've been saying. So I think the answer to that really is a mix of both. Like you're learning the framework, and I think giving yourself a project to work on in the framework is excellent. But like Joe is explaining, you want to go and build just bag 1, and then as you keep moving on, you're going to come up to something else where you need to go focus on building just bag 2, and then bag 1 and bag 2 kind of fit together, all the while you're sort of building this Star Wars ship all at the same time. So I would say it's a good mix of both.
And there's another reason why, another piece of why I recommend focusing on the framework and then just learning language as it comes along. And that is that then it allows you to build something for yourself. I was talking about the practicality of getting the job, but it also allows you to build something for yourself. And that means that you can work on a personal project. But usually when you learn the underlying language, building something is going to be a lot more difficult. That's the reason that frameworks exist, is because they just make it faster to actually build things, right? React exists because it's faster to build something with React than with vanilla JavaScript. So for the same reason, you can start working on a personal project and see results from that personal project faster by focusing on how to do stuff in the framework, even if you don't understand everything in the language, and then coming back and taking time and learning more and more of the language. And from my own personal life, when I learned JavaScript before there was much in the way of frameworks, but I tried to learn a little bit and didn't hardly get into it at all. I was struggling and not learning it very well. And then jQuery became popular, and I started learning jQuery. And with jQuery, man, I could quickly do stuff, and it was amazing. And I would say, and this was true for a lot of programmers at the time in that like 2005 to 2010, 2011 era, you knew jQuery, you didn't know JavaScript. And interviewers, when you went to a job, they just wanted to know if you knew jQuery. They didn't necessarily care if you knew JavaScript. That's switched nowadays, but for a long time, I was very comfortable with jQuery, but I was not very comfortable at all with JavaScript itself, and certainly the DOM. I didn't know the DOM at all, but I knew jQuery. So but I became a front-end developer and had a very effective career for quite a while. And still today, I feel like I'm learning JavaScript. I'm always trying to dig deeper and finding new opportunities to learn JavaScript deeper. But in every case, I focused, on the framework. It was jQuery and then Knockout and then Angular JS. And I was really focused on the framework. And I just learned more and more JavaScript as time went along. And I also spent some time and devoted some time to it, but I really focused on the framework.
Those are great questions.
Yeah. All right. Well, I guess that's it for our Q&A. And we can wrap up our recording. Thanks again for those who stuck around to the end.